Hey guys, welcome to my mess. Today we're going to start to talk about using the lab materials to start to build circuits and do experiments in electronics. So I think I put together a kit that gives us everything we need to get started. And so today we're going to look at the pieces and then we'll do a little experiment. So to get started, let's take a look at what we've got. So here we go. So to build circuits, we need components and a breadboard and power supply. So to just build circuits, that's what we need. And when I talk about components, I'm talking about wires and resistors, capacitors, diodes, transistors, all the things that we'll use to control the electrons in our circuits. And we need a breadboard. That's the substrate that we'll use to uh, build our circuit on. So instead of having to solder components together or use clips or something like that, the breadboard allows us to organize our circuits pretty much the way we draw them on a sheet of paper or in a CAD program. Um, and then, of course, we need a power supply, so a source of electrons to move around our circuit. And then we need a way to test the circuit. And so we have two fundamental pieces of test equipment. One is a digital multimeter, and the other is a USB connected multi-purpose instrument that I sometimes refer to as a lab in a box. And in this device, we have a power supply, a waveform generator, a voltmeter, an oscilloscope, a data logger, a logic analyzer. We'll configure it to make it a curve tracer. We'll do quite a few things with this. So let's take a look at these items. So we'll go to the bench. Okay. So here's the bench, and these are the four boxes that you receive to work in the lab. So this bag contains connectors that you'll use to connect this, which is the multi-purpose USB instrument called the Analog Discovery 2, to your circuit. And you'll connect this to your PC through a USB port, and you'll run some software called waveforms that we'll talk about downloading in a little while. Then you receive this box. This box contains a digital multimeter, and then finally this box over here. This box contains all the components that we'll use during the semester, and there will be some additional components that I supply after the first exam. So, okay, so that's basically our kit. Let's open it up and follow along if you like, and we'll see what's here and what it's used for. Okay, so bench view. Okay, so now we're looking at the bench, and we'll open this bag with the connector in it. This bag has two things in it. It has what's called a breakout board. So let's move all these other boxes to the side for the moment. So it has a breakout board, which is in this bag here, and then it has this connector, which is called a ribbon connector, and it's very colorful. And every color here has a meaning. It's connected to a particular thing in the particular pin in the analog discovery 2, and we'll learn how to make that connection when we get to the analog discovery 2. So I'm just going to open this up. I guess I need something to snip this with. There we go. Pull this out. And so this is a header connector. And this header connector is what makes the connection between this what's called a breakout board and this connector here. But we'll put this aside for a moment, and we'll come back to this when we've unpacked the analog discovery 2. Okay, so the biggest package is this, and so again I need something to open this up with. And when we open this up, there's a bunch of things. So there are these packages that contain components called resistors, and then there's this ribbon cable, and then there are these colorful wires, and we'll call these hookup wires. And there are several different lengths, but most of them are these short lengths, and they come in many different colors, and I'm not sure if every person gets the same variety of colors as every other person. Okay, and then continuing to take things out of the box here, there's a USB cable, which is USB-A on both sides, and there are these, which are snap-off headers. You can make an impromptu type connector with this. I'm not sure we'll be using these. And here's the breadboard. Now the breadboard has already plugged into it, at least when I took mine out, this module here. And this module can act like a power supply. Let's see if we can't zoom in a little bit. So we'll zoom down here, and there's the top of the breadboard. And so one of the things you can notice at the top of the breadboard is that there is a we call this a bus, and all of these holes along this bus are connected together, and they're all labeled plus, and they have this red line. They have this red line next to it that indicates that it's plus. So all of the holes that are next to that red line are places where it's intended for you to make it a positive supply voltage. And then there's the blue one, which is a marked negative, and the same thing on the other side. And this power supply, I'm not sure we're going to use this power supply, but this power supply, let's see if I can get the right angle here. This power supply will plug into the bus. Get it right. And and can supply power to your circuit. And there are a number of locations here, jumpers that will set the voltage for each side. So you could have 5 volts on the left and 3.3 volts on the right, and it all comes from being connected to a USB port through this connector. So that's what that power supply is all about. And as the semester goes on, we may decide to use it or we may not decide to use it, because our analog discovery 2 actually allows us to gives us a power supply as well. And one of the things we want to do with the analog discovery 2 is be able to connect to plug this breakout board into our breadboard, and doing that over and over and over again um, is not the best practice, because these pins, so if you take off the styrofoam, these pins are a little fat for these holes, and if you keep plugging it in and out, it's going to expand the holes, and every time you do it, you run the risk of bending these pins, and we want to avoid that at all costs as well. So as we go on, we'll figure out how we want to do this. So these wires are meant to also plug into the holes of the breadboard, and I'm going to have a tray here so they don't go everywhere. So we have a number of colors, and generally speaking, we use black wires to represent minus, and more often than not, minus represents ground, and so and they just fit in the holes, and they allow us to connect points on the breadboard together by sticking the ends in the holes. So let's get to the components. So wires connect components together, and the breadboard gives us the opportunity to connect a component to connect 2 components together, or 3 components together, any number of components. Okay. So now there are these little boxes that contain components, and zoom in a little bit. So this box, when you open it up, has how do you do that? One more. Okay. This box has all of these tiny little cans. Oh, it has a lot more than that. Let's dump it out. Okay. So these tiny little cans here, they are all capacitors, and the cans are probably, if there's anything dangerous in this kit, they're probably the most dangerous thing in the kit, because they're a special type of capacitor called electrolytic, and it means that they have a polarity, and if you connect them in the wrong polarity, they will outgas, and sometimes there'll be a little explosion on your desktop or your bench. So just be aware of that. So I need to organize these components a little bit. So I have these, I don't know, if you like mochi, when you get mochi, mochi comes in these little containers, which are great for organizing these small components. So those are electrolytic capacitors. And then these little discs, are ceramic capacitors. And so we'll find a place to put those. Now these components right here are very special. Let's try to zoom in a little bit on this and see if we can't see these better. Autofocus is not so great tight like that. So we'll go back a little bit. But this component is a photoresistive cell. When light hits this cell, it's one of its properties, the property of resistance, goes down, and you can use that to measure the amount of light that's hitting it. So that's what these are, and there are two of these. And then the final two components that were in that little box are these, and you can guess that these are LEDs, and they're kind of special LEDs because there are actually several LEDs in here so that they can light up in different colors. So we'll put those in our little mochi organizer and go to the next box. So the next little box, open it up. Empty it out. Let's zoom out a little bit. Okay. So this has a wide variety of different types of components. So these little discs, just like in the previous container, these little discs are capacitors. And if you look on the side, I don't think I can zoom in properly so that you can see what is said, but there's a number on the side that's a component code, and it's 104. And if you recall the exercise we did in Lab 0, where we had to work with the component codes, so this is a 1 and a 0 followed by 4 zeros as the value, and the units for that are used by these component codes, the units for that are picofarads. A picofarad is 10 to the minus 12th farads. Capacitance is measured in farads, and most capacitors, well, all the capacitors that we'll use this semester in the class will be quite small. Okay, so here, these components that I'm arranging here, these are little push button switches. So push button switch, which is really tiny, but will it fit in the breadboard? Let's find out. So it does seem to fit in the breadboard. So that's a good thing. Okay, so we've got those little switches, we've got some capacitors. This here is a little loudspeaker, and we can use it to hear signals. We can hear, we can generate tones, and we'll be able to hear them with the loudspeaker. Let's see what else we've got. We've got a second loudspeaker here as well, I think. Or one of these might be a microphone. So as the semester goes on, we'll find out. This is an integrated circuit. Another switch. These three terminal devices here. So three terminals, three terminals, three terminals, three terminals. Those are what I'm going to presume are transistors. Another capacitor. These two terminal devices that are black epoxy case with a silver band at one end. These are diodes. So the diodes are another type of semiconductor device. These little black eggs, I guess you'd call them, with two terminals, these are a mystery to me. They could either be a type of capacitor called a tantalum capacitor, that tantalum capacitors usually look like this, or they may be a device called a thermistor, whose resistance changes with temperature, and they allow you to measure temperature with a thermistor. So that's cool. And I think we've gone through everything except this one white package here. And this one white package is also a mystery. We'll have to look that up, but I think it might be an optical isolator. And we'll talk about why that's important at some point during the semester. And so now we've got those sorted out. So we've got capacitors, and we have two audio devices here. One is probably a microphone, and the other is a loudspeaker. And then we have push button switches, transistors, integrated circuit. Here's another integrated circuit, which I think may be an optical isolator. Then we have these two, which I think may be thermistors. And we have these, which are transistors, and these, which are diodes. And there's one more component in here, this blue component. And so this blue component is called a potentiometer. And potentiometer is a resistance that you can change by turning the knob, like a volume control on some audio device. Okay, so I'm going to organize these pieces, and we'll go on to the next container. Diodes, transistors, and there may be several different types of transistors in there that we will try to figure out at a later date. And so as we go through this, we can start to classify some of these things. So for example, a microphone and loudspeaker, they would be called transducers because they take things from the physical world and turn them into electrical signals, or vice versa. This integrated circuit, we'll find out what it is in weeks to come, but I'm going to guess that this is a type of amplifier which allows us to take small signals and make them bigger. This is an optical isolator which allows us to take a signal and remove any connections to the power supply from it. Okay. Move on to the next box. Now this next box is, well, you can easily tell what's in this box. These are all LEDs of different colors, which is why I think they call this the fun kit. People like to see lights blink, and this certainly is a lot of lights that you could connect and make them blink. So, so I'm not even going to take these LEDs out of the little box because they're all the same. Okay. So those are our components, and we didn't look at the resistors. Let's just open one of these packs of resistors. So the little plastic bag tells you what's in the plastic bag, and if you open it up, you will find that all of these resistors are held together with a piece of tape on each end. And this is actually the way they would go into a machine that assembles a circuit. Um, the the important thing for us to notice here about the resistor is that it has these colored bands, and these colored bands allow us to they represent a component code, and from that component code we can determine what the value of each resistor is. So the component codes consist of 3 different numbers, and so there's a color that represents 1, a color that represents 0, and then there would be 0 zeros after it. So so 1 is brown and 0 is black. And so many of these components will be 2 of these should be start with a brown black, and this one will be brown black black, and this one will be brown black brown, and then this one will be red red brown, and this one will be orange orange brown. So as we progress in building circuits, we will become used to looking at these colors and determining what the values are. And the way you remove, the way you pull resistors out of these cases is you can cut them out with scissors. And I would suggest cutting them out one at a time as you use them, and that way you don't have a bunch of resistors on your bench that you have to look at the individual codes for to determine what they are. Just an organizational principle. Oh, and they were nice enough to here put, oh, these are 10 ohms. Let's see if all of these have labels like that. Yeah, there you go. So these are the 330s, orange, orange, black. Sorry, orange, orange, brown. And these are the 100s. So this should be brown, black, brown, black, brown. and these are the 220s. Now there are more 220s than anything else because they gave you a lot of LEDs, and 220 ohms is a common resistance to use with LEDs. Anyway, so you have a lot of resistors, not as many as we have in our lab, but there are quite a few of them. So that's the resistor packs. Okay, and then the final box is this, and this box contains pre-cut and pre-shaped wires that that you can put in your breadboard. So short ones, maybe medium one, another medium size, something longer. You get the idea. They're all different lengths, and if you were building something that was pretty complicated, maybe you would want to use those wires over using these wires. Okay, because these wires, every time you put in one of these, you get a big loop. Okay, so so those are the components. Let's take a look at. So I'm putting all my wires together here. Let's get a little wider now. Breadboard, power supply. We may use this power supply for the first lab, but we wouldn't use them for all the labs, because some folks in the class only have one working USB port, and so this would require a second USB port. Okay, so now here's our digital multimeter box. Let's open this up. And what have we got in here? We have data sheet, some instructions, and a diagram. And I encourage everybody to read this, to look at the diagram, to get familiar with the device, as well as just pay attention to us discussing and me demonstrating. So now I've cut this plastic wrapper open, and I'm going to pull the plastic wrapper off. And this is what the device looks like. Now, I didn't see any batteries in the package, so I'm not sure if this is going to work when we turn it on or not. So let's see. Look, it works. There's a battery in there. Fantastic. Okay. So, so the way you turn it on is you turn this knob. And this knob determines whether you're going to measure voltage or resistance or current, and it may even be able to generate a little pulse train waveform. And here it can measure continuity and diodes, and it has a backlight that you can turn on or turn off. Well, I don't know if you can turn it off. You can hold on to a measurement. So how do you use this? You make measurements with probes. So this bag contains the probes, and there's a red probe and a black probe. So these are the ends you use to make the measurements, and these are the ends that you use to connect to your meter. Now you see you have two probe ends, but you have three different places where you can stick these. So let's get a little tighter here. Okay. So the terminal named COM is the one we're going to stick the black probe in, because the black probe always represents the negative. And then I don't think we will ever use this hole here, because this hole is for 10 amperes, and we'll never be measuring that much current. So, and this one says volts, ohms, milliamps, and whatever that means, signal. How do we figure out what that means? Well, we can go to the documentation and look for that icon. We can measure AC and DC voltage. We can measure resistance. We can measure diodes. We can, yes, generate a test signal. The test signal changes 50 times a second, and the voltage will be 5 volts. Okay, so right, so that means so that little pulse indicates that when we're in this spot, we're generating a signal, which is not the best thing to do. But it gives me an idea. So, so I wonder if that pulse is big enough to light one of our LEDs. I'm going to guess probably not. But, and we'll try it. So I'm going to take my LED and plug it into the breadboard, and if this, we'll see if that will light the LED. So an LED has a polarity, so I don't know which side is positive or negative, so I'm trying it this side first. And then I'm going to go this side. Yeah, it's certainly not enough to light the LED. Okay. Was a nice idea. You know what might light the LED though? Is trying to actually measure it. So when this is in a diode setting like it is now, it generates a voltage that oh, look at that. It generates a voltage that may saturate the device, and it does. So we have used it to light this LED. Now, I know my hand was covering the screen so you couldn't see it, but I do that, the LED is lit, but nothing is showing up here on the screen. And that's because LEDs are not your usual diode. LEDs LEDs have what's called a forward voltage, a large forward voltage compared to a standard diode. But we're getting way ahead of ourselves. This is weeks into the course, so we're going to stop that, and instead we're going to take a little time to look at measuring resistance. But actually, I think that will be a separate video because we still haven't looked at the analog discovery too. So, so happy that this came with batteries inside, and the manual should let us know what's in here. So it says included accessories are user manual, so that's this. Set of test leads, that's this. But yeah, and then multifunction socket, that's for a different model. And it takes a 9-volt battery. So there you go. And it doesn't tell you how to, oh yeah, it does, how to replace the battery. And there's a low battery indicator on the screen, and it's important to pay attention to that. So if I turn this on right now, there is no low battery indicator, but you should check that when you use it, because if you leave it on and the battery gets low, you will not get accurate measurements. Okay. All right, on to the analog discovery. We're going to open it up. I'm going to show you how to connect it, but this analog discovery requires an entire video unto itself because there's just so much. So let's get wide so we can see the whole box. Put my lids away. Rid that, and here we go. So you can throw the packaging away. And take everything out. Okay, so this pinout diagram is very helpful. So this connector is called the flywire connector. And when I open it up, you will see that there are many multicolored wires. Some of them have stripes and some of them do not. So for example, on the end here, let's try to get a little tighter on this. Okay. So on the end here, so the first two are orange, but the thing that differentiates the two oranges is that the one here has no stripe, it's solid orange, and this one here has a white stripe. It is different. Okay, and you can see here in the legend what these wires represent. So here, this is a scope probe positive. Here, this is scope probe negative. Whatever you do with the analog discovery 2, you will always need to connect a black wire somewhere in your circuit. So the blacks are the grounds, and And so we have ground here, and here, and here, and here. So we have 4 different places where we can get a ground connection. They are all connected together internally, and they are all the same. Okay, let's get a bit wider now. So the things in the other bags. So fly wire connector. There's this plastic bag that contains headers. Headers are just stiff pins that we can use to make connections to the fly wires. But this whole these stiff pins, we're going to replace that whole thing with the breakout board. And so we're not gonna. So my recommendation is to not use the fly wires and instead use the breakout board plugged into the top of your breadboard like this. And then yeah, I did that a little askew of where I wanted it to be. Let me grab a tool here. So if you have to take this out, you do it very gently and carefully and try to pull it out straight. Okay. So now I'm putting it in so that it's centered on the board. So now let's try to get a little tighter again. So now all of these indicators here tell you what these pins mean. So there's our grounds, ground there, there's a ground there, there's a ground there. This W1 and W2, those are 2 waveform generators. This V plus and V minus, those are plus and minus power supplies, 2 separate power supplies. And then these are the analog inputs that we'll use to make measurements. So channel 1 plus, channel 1 minus, channel 2 plus, channel 2 minus. And we won't be concerned with the rest of this unless we come up with an experiment for those things. But these are basically the digital inputs and outputs, and we will use those when we get to digital electronics. Okay. So there are a couple of ways. So you saw in the beginning what I did was I took this header connector here. Let's see if I can get it out now. See, so once you have these things in, you should probably just leave them in. So this header connector piece gets connected to that header like this, and now you have pins coming out. Now, this is the ribbon cable that's going to connect to the analog discovery too. Let's get a little wider. Okay. So this ribbon cable has a key on one side, but doesn't have a key on the other side. The side with the key goes into the analog discovery too. Okay, can you see that? The key goes into the analog discovery too, like that. And then this cable is not keyed, and so it's possible to put this in incorrectly. So recall when we were looking at this that there's cables with a stripe, and there's wires with a stripe and wires without a stripe. And you can see the same thing here in this cable on this side. Those are all the solid colors, and on this side, these are all the striped ones. So so you want to find the location with the solids, and you want to have the solids facing you as you plug this into, so as you plug this into the breakout port. And it takes a little force to do that. And my suggestion would be that so once you have this whole thing connected like this, you leave it this way for the entire semester. And that will prevent you from taking it apart and putting it together incorrectly. Okay, so I have this way. These wires all have no stripe. The wires on the other side, they're the ones with the stripe. Okay. So the last piece is the USB cable. The USB cable is going to connect to your PC. So take it apart. So one side of the USB, the micro connector, is going to go into your analog discovery, and the other side is going to be connected to your PC. And on the PC, there will you'll need to install some software from the Digilant website called Waveforms. I believe it's called Waveforms 2015. And that waveform software gives you the ability to control this device and configure it to be any of those things we were talking about before. So so that's my introduction to the lab materials. That's my introduction to the lab materials, and I hope you were able to follow along. And if you weren't, go back and slow it down. Pause the video, take a look at all of the components, and how to connect the analog discovery 2 to the solderless breadboard. And we'll talk more about that in the next video, where we prepared to build and energize a circuit. And that will involve installing the waveforms software from digilant.com, and learning how to use that, which it's pretty user friendly, but it's not. There are ways to get confused. So but we'll go over all of that. Okay. So I'll see you in the next recording. Take care.